So we've got an application here. We've got a rain gutter. Is to be constructed of aluminum sheet that's 12 inches wide. That's this sheet right here. After we make marks every 4 inches, and what we're going to do is at those marks, we're going to bend it up some angle theta. So what it's going to look like, this little rain gutter is going to look like this here, okay? And so each of these are 4 inches. And what we want is we actually want this area right here. That's what we're looking for, okay? In terms of theta. All right, so how do we do that? So where's the theta coming into play? So this angle right here is theta. And so this angle here is theta. Now, to find this area, okay, I'm going to split this up into 3 regions. All right. Now, what do I know? What do I know about if I have 2 lines that are parallel and I've got a transversal that runs through it? What do I know about this angle here and this angle here? Ooh, that's a little too big. Let me do it like this. This angle here and this angle here. These are alternating interior angles. So if that is theta, then this is theta too. Okay? So I kind of have an idea now. I've got a triangle here. So I want to express the area as a function of theta. So the area as a function of theta, all right? Well, I want to let B denote the height, the vertical height. So that vertical height there is the letter B. So that's also B here. Okay. So to get this middle area here, I multiply B times 4. All right. So that's B. Oop. Let me do that. B times 4. Okay. And to get this area here, well, I need to know a little bit of trig. So to draw it out for you, you got your right triangle. This is 4. We know that's B, and we know this is theta. So I need to know the legs. So I don't know what this is here. All right, so one thing that I can do is I can do the cosine. Okay. If I do the cosine of theta, the cosine of theta is equal to, well, adjacent divided by hypotenuse, which would be x divided by 4. All right. So that gets me this side here. So if I multiply both sides by 4, I get 4 cosine theta. Okay. So this side here is 4 cosine theta. Okay. Now, what else do I know? Well, the sine of theta, what is the sine of theta equal to? The sine of theta is B divided by 4, right? B divided by 4, so B divided by 4. So I can replace B with 4 sine theta. So B is equal to 4 sine theta. So instead of having B times 4, this is actually going to be 4 sine theta times 4. Okay. So that's that middle rectangle there. Now, finding the area of a triangle. Area of a triangle is 1/2 base times height. So the base times the height. So my base and my height here, that's 1/2. And then base times height, that's 4 cosine theta times the height b. What is that? That's 4 sine theta. Okay. And then I have the same thing over here. Plus 1/2 4 cosine theta times 4 sine theta. Okay. So, let me move all that. So this becomes what? So if I have a half here and a half here, I have a whole. So 4 times 4, I'm sorry, 4 times 4 is 8. I'm sorry, 4 times 4 is 16. Divide by 2 is 8. All right, so I have 8 there and 8 there. So that's 16 cosine theta sine theta total. And this 4 times b, all right, that's 16 sine theta. So 16 sine theta plus 16 sine theta cosine theta. Okay? And if you want to, you could factor out a 16 sine theta, and you'd have 1 plus cosine theta times 16 sine theta. So that would be the area, this region right here. Okay, that shaded region in pink. Okay? So the trick here is using trigonometry, those trig functions, to get that side length that we did not know what it was. Okay? And then I use my area formulas and I add the three separate pieces together. Okay, so the area for the middle of base times height. All right. Now, the second part says that I want to graph my area function, and I want to find the theta that makes it the biggest. So we need to use our calculator, and we'll do our maximum value. Okay, so let's go to our calculator. Calculate. Skip for now. Okay, let's go in here. Clear. And so I want to graph. I'm going to graph 16 sine x, and I'm going to do parentheses times cosine x. Excuse me. All right, we're going to get through this. All right, and then plus 1, and close my parentheses, hit enter. I'm going to graph this thing. Now my theta here, I'm going to restrict from 0 to pi over 2. Since if I angle it up any higher, then it's going to cause issue for us. If you think about it, why would I not want to angle it any higher than pi over 2 for theta? If it's pi over 2, then it's exactly... excuse me, a 90-degree angle there. And so you can clearly see that this area is greater than that area there. Okay, so it's definitely, your angle here is less than 90 degrees. Okay, so I'm going to find the maximum, second calc, and I'm going to calculate the maximum. I'm going to get on the left side. I'm going to get on the right side. Okay, so it looks like the maximum is a x value of 1.047. So theta equals 1.047. Now, you can leave it like that, or you can convert that. If you convert it to angle for degrees, That's 180 over pi. Okay, so 180 over pi, so let's do this. 1.047 times 180 divide by pi. That's really, really close to 60 degrees. Guess what? 60 degrees is pi over 3. And I bet you if you typed in pi over 3 in your calculator, you would get this radian. Okay, so either way, if you want to do it either way, that's fine. Okay, whatever it asks you for in your problem. So that's an application problem for actually using trigonometry, figure out the maximum area. Okay.